Well, in the previous class, we were talking about the network layer protocol and the data link layer protocol, and the addresses, how we use those addresses for configuring the end devices in the network, and how to configure the network devices in the network. So, by once the end devices or network devices are configured with their IP addresses, so then it is the next step is to verify whether the devices in that network are reachable or not. So for that, one needs to check the what you call it's the connectivity checking will be required. So in this connectivity checking, for connectivity verification of any two hosts or any the client and server concept communication, then it is required to verify the connectivity by using a special protocol which is available in the predefined protocol in the TCP/IP suite. That is your ICMP Internet Control Message Protocol connectivity verification tool. So in this, we try to identify and we try to explain the ICMP, how it is used to test the network connectivity, whether the host in the network are reachable or not. And then we try to use some commands, that ping command or your traceout utilities command, to trace out the network verification in this. So in the ICMP protocol, if you see, it is a inbuilt protocol service of your TCP/IP suite, which provides this particular message is used to send if any events are occurring with certain errors. That means these messages send using the services of your ICMP. So what are those mean? The purpose of this message is to provide the feedback about the related issues, why the certain errors happened in the event of connecting the source to the destination. Let me just pause here. Yeah, so here it is having the ICMP, it will give you the feedback that what exact issues happened on the other side or on destination side or server side. So these ICMP messages are not required for any security reason purpose, but it is just to require whether the hosts are reachable or not from source to your destination side. So as we have seen in the previous lecture that there will be two different networks which are using different IP addresses like IPv4 and IPv6. Similarly, this Internet Control Message Protocol is giving service for IPv4 as well as your IPv6 by giving the version as your IP. I mean the ICMP version 4 and ICMP version 6. So this message that common for both the IPv4 and IPv6, but it includes mostly the host confirmation, whether the host is reachable or not, and the destination or the service unreachable, and what is the time exceeded for that particular message, and the route directions will be given by this message. So in this, if you see in the host confirmation, first one, if you call the first part the host confirmation part. So in this host confirmation, the ICMP echo packet will be sent from source to destination. If you consider this network, there are 4 hosts are there. So these hosts are configured with the IP version 4 to identify these host 1 and host 2 in this network. So in IP version 4, they are identified with the what you call the IP addresses. So host 1 is identified with the IP address like 192.168.10.1. This is a private IP address which is used to identify a device in the private network or in local area network. And another host in this network is host 2, which is identified with the IP address that 192.168.30.1. Okay, that means this is another private network. This is another private network. So how to identify whether both the host 1 and host 2 are in the same network or different network? How do we identify that? Whether host 1 and host 2 are in the same network or in the different network in this case.
We use the subnet mask to figure out what is the network portion of the IP address.
Okay. So from here, we use the IP address for the H1 is 192.168.10.1 and host 2 using the IP address 192.168.30.1. So by looking at these IP addresses, can we say that both the hosts are in the same network or in the different network? Simply says they are in the different networks because the third byte of this network is 10, third byte of this network is 30. So the host 1 is also using the 1 for its identification purpose and host 2 is also using 1. That means if two different hosts, if they are on two different networks, they may have the unique identity. But if two different networks in the same network, suppose 192 dot for this host 3, 168 dot your 10.1 is not accepted. It will give you a conflict. In that, host 1 and host 3 must have a different identification. But if they are in a different networks, they can use the same unique ID. Okay. And one more thing, if the hosts are at different network, the network address should be different. So in this case, there are two different networks are there. One is the 192 to 10, another one is 192 to your 30. Different networks are there. To check it out, the host 1 is trying to check the connection, whether the connection is reachable to the host 2 or not. So for that, host 1 use the ICMP version 4 message or control message packet, and in that packet it will try to ping the host with its identity, that is 192.168.30.1. If it is reachable, this echo request packet will go through the network and reach to your destination if it is reachable. If it is reachable, then destination, that is host 2, will respond to the request. When it respond to the request, then we can say that the connection is reachable, and after that the host 1 can start communicating with the host 2 by sending the actual data or actual messages. So the local host here, the H1, sends the ICMP echo request to the host on H2. So we can see this, the animation, to check it out whether they are reachable or not. So host 1 try to send a ping packet to your host 2. So it gives the connection verification of your host 1 to host 2. So that is the first step after configuring the devices in the network. So in ICMP version 4 messages, it gives the destination or service unreachable messages. So that is the event which is occurring with an error, suppose. So what happens when a host or a gateway receives a packet? So gateway means, if you consider in this network, can you please tell me what is the gateway of this one? Suppose let me give the name as H1, H2, your H3, switch 1, your router 1, router 2, switch 2, your H4. Can you can you please tell me what is the gateway of your first network? Hmm? In this one. What is the gateway for host 1? R1. What's the gateway for host 2? R2. Okay. What is the network edge router of R1? I mean the H1. What is the network edge router of your host H1? Any other guesses? It may be gateway, it may be network edge router, it is same R1. Because that is the edge of your network. After that, it will goes to the public network. So this kind of questions you will expect in your text. Okay. So here what it says, when the host or your gateway that receives a packet. So in our case R1, if it receives a packet that cannot be delivered to your suppose R2 all the way, or H2, maybe because of the disconnection of this link between your R1 and R2, then it is the job of your R1 to send a ICMP packet back to your H1 to inform that your H2 is not reachable. So that it can generate the ICMP packet for the destination unreachable message to notify your H1 that the destination H2 or the service is unreachable. So this control message that includes certain codes. So what are those codes means? If it is the packet, echo packet from your H1 is not reachable to your H2 based on various reasons, it may be because of the network unreachability, or if network connections are there but a host is unreachable, that means the host is not configured with the IP address. If network and host are present but it is possible that the host is not running the protocol service may be disabled, or maybe because of the port numbers unreachable. So these are the cases. So in this IPv4 control message, it contains the code, and that code informs the host 1 in our case that if it is that ICMP code is having message, if it is included the code 0 means network unreachable. If it is included 1 in that means host unreachable. If 2 means your protocol unreachable on the destination side, and 3 means the port unreachable on destination side. So these are 3 different code. So you may expect the question that the ICMP message that included the code 2. So what it informing to the source? If the ICMP message includes the code 2, then what it informs to the source? Yeah. So it says that the host is reachable but the protocol is not reachable. Okay. So the another part is time extended one. The first one is your control, the host confirmation will be there as part of your ICMP. Second, it gives the destination of service unreachable. Third one is the time exceeded. That means if any packet is traveling in the network, at some point it must be terminated from the network, or else unnecessarily that packet which is not usable by any of the hosts in the network can still consume some of the bandwidth in the network. So this ICMP4 time exceed message is used by the router to indicate that the packet cannot be forwarded because the time to live field of the packet was decremented to your zero. So what it means, if you take our previous example, the host one sending a message, so then it is going through the switch, and after that it is going to a router, then it is going to another router two, router one to your router two, and from there it is going to your switch two, suppose, and from there it is reaching to your host two. So based on your network layer, the property of your network layer, it tries to find a route from source to destination, either following the static routing or your dynamic routing. So when it tries to find a route from source H1 to your H2, the network layer protocol of your H1 provides that this is hub 1, this is hub 2, second hop, this is third hop, fourth hop, fifth hop, and your sixth hop. Reach. So then whatever the echo packet which is generated by this host 1 will have the time to live, that is 6 hops travel from source to your destination. So as this packet goes from your H1 to H2, here the time to live will reduce from 6 to 5 because it's traveled one hop. When it reached your R1, the packet time to live reduced to 4 because it's reached, traveled 2 hops. And when it reached to your H4, the similar reduction will be gone. Ultimately, when it reached your 6, it will get the 0 hops. But after that, even though it is received by host 2, to whom it is intended, but after that, if this packet is traveled back to your switch, suppose, then switch will simply drop that packet because the time to live is 0 in that. Further, it cannot reduce to -1, -2. So that's if a router receives the packet and decrements the time to live field in the IPv4 packet to 0, then it discards that packet and sends a time to live exceeds the message to the source host, so that it is informing the source to regenerate the new echo packet and send it back. So this that is the concept of time exceeds. So in this message, the IPv6 or for your IPv4, it has 4 new protocols as part of your neighbor discovery protocols, ND. Neighbor discovery protocol, or you can write as ND or NDP. So in this neighbor discovery protocol, messaging between the IPv4 router and IPv4 devices. Sorry, IPv6 router to IPv6 devices. Devices means your end devices. So the router solicits message and the router advertisement messages are included. These are the additional functions of your ICMP version 6. So the message between the IPv6 devices means your H1 to H2 in the same network, in the same local area network, they can give the message that neighbor solicitation message and neighbor advertisement messages. So this is the verification message which gives by your IPv6 router to your switch, that is source and destination. That is the request send and your request acknowledgement or request reply for that. So in this IPv6, the router solicitation, in that the messaging between your IPv6 router and IPv6 device, if you see here, so this the RA, that message are sent by your router no, to provide the addressing information to host using the stateless addressing auto configuration, we call this slack. So in that it sends to all the IPv6 devices which are connected to your router R1, suppose, by giving the router advertisement that what are the stateless auto configuration information is there. So upon receiving that particular information by the IPv6 devices, that is your host part, okay, they will respond to this IPv6 router, the advertisement by giving the IPv6 router solicitation to all the IPv6 routers which are multicasted this information. So these routers will send a RA message periodically or in response to the RA message, so that a host Slack will set it default gateway to the link local address. So that is inside the network, not outside the network. If it goes outside, it will be the public network. So when a host is configured to obtain the addressing information automatically from your router, then the host will send the RS message, the solicitation message, router solicitation message to your router, requesting an RA message, the advertisement messages. So here, this particular issue will solve the address resolution. So this address resolution will be solved by messaging between your IPv6 devices. So that is your host 1 and your host 2, whose IPv6 devices. How the NA messages, we call the unicast messages we care. So these network solicitation messages are sent when a device, it may be your host 1 or host 2, that knows the IPv6 address of other device in the network, but does not know its MAC address. They only know the IP addresses, IPv6 address. So in that case, the address resolution protocol is requested. We'll talk about this more in the after this topic. So in this NA messages are sent in a response to the NS messages. This for the to any sender of your NS for your unicasting, that is 1-to-1. So this neighbor advertisement and neighbor solicitation messages will be exchanged to by in terms of bus. They first send the IP address. So based on IP address, they create one packet, that is the neighbor, the solicitation packet, and send it to the unicast it to the network device, sorry, the end device in the same network. So it says that I know only the IP address of the host 2. So what is the MAC address of this means? By using the IP version 4 or your IP version 6 message just consists of your source IP address and its MAC address in that message. That will be broadcasted in this network. So your router will simply broadcast that, multicast that particular packet into the network, so that will be reached by, or that will be received by the host in that network. And upon receiving that, every host, they try to compare their IP addresses. So host 2 is also trying to compare the IP address of the packet. If it is matching, then any of the host, they can respond that, yeah, that's my IP address and here is my MAC address. So your MAC address of our host 2 will be added to that particular packet and will be the MAC address added to that, and that will send back to the source. So that's the way your router will build a routing table. The routing table, in that it will have the IP address as well as the MAC address of every device in that host. So the duplicate address detection can be done using this ICMP, your router solicitation and your router advertisement. So when a device is assigned a global unicast or the link local unicast address, the DAD, that is the duplicate address detection, is performed on the address to ensure that it is unique. So upon when it is initiated to check the uniqueness of the address, the device will simply send the neighbor solicitation message in this particular network. So to solicitate any node, it will multicast in the network by using the ICMP version 6 neighbor solicitation message. So upon this message is received by the host in this network, so then they can respond to that whether that message is belongs to them or not. How? So let me make sure my IPv6 address is unique. Whoever has the IPv6 address, so send me and your MAC address. So based on the IP address and the MAC address which is associated with that IP address, will detect whether the same IP address used by different MAC or not, because MAC address is unique for every device. The physical address is unique. So if another device on the network has the same IP address, then it will respond with the network, so the neighbor advertisement message, which will notify the sending device that the address is already in use. So don't use that IP address. Okay. So after getting that, you are trying to reach the devices in the network. How to find out means by doing the ping and trace out utilities. So let me just play this for you so that you can understand. Let me play this video for you.
Everyone, we are here to do network testing and verification. Not using the GUI, we're going to be using the CLI, the command line interface inside of our Windows 10 box. Now to do it, we can get there a couple different ways. It really starts with start. If you wanted to, you could type in command prompt and that would take you pretty quickly right to it. Or we can use start and take the longer route, that being run, opening.
Just give me, let me just record this session too.
Hello everyone, we are here to do network testing and verification. Not using the GUI, we're going to be using the CLI, the command line interface inside of our Windows 10 box. Now to do it, we can get there a couple of different ways. It really starts with start. If you wanted to, you could type in command prompt and that would take you pretty quickly right to it. Or we can use start and take the longer route, typing in run and opening a run box. Or I can use Windows R to get to our run box, or I can right click on that start button and click on run and get a run box. From there in the run box we would type in CMD, like cat mouse dog, CMD, and click OK. And from there it opens up our command prompt. I'm going to resize it a little bit for our video purpose. That's looking great. And now what I'm going to do, just for more room of typing, I'm going to type CD followed by a backslash and hit enter. And this will just take my prompt back to the directory of root directory, the C drive. This is just for purpose of having more room to type. So I'm going to use the first network testing command I want, and that is ipconfig. And when I enter the ipconfig command, we get some basic info here. I get the IP address of the end device I'm on, which is my user computer, which is 192.168.196. I get the subnet mask, which talks about the network size, how many IPs exist on this network. I have the default gateway, which is the router's IP address that my machine is going to leave the local network. Now this is all fine and great, but if I want to see more info, like what DNS server is my user actually utilizing in order to go out to the web and search names? Well, to get that type of info, and also to get info about my MAC address of my device, I would use the command ipconfig /all. And when I hit enter, it's going to be a larger output. So here's the original command at the top, and here's my output. The name of my device is displayed. The MAC address, which is known as the physical address of my machine, is also displayed. Below that, we get more info as well, such as here is our basic of info we saw before. Link local IPv6, my IPv4 address, subnet mask, default gateway. But check it out, we even get the listing for our DNS server, who we're going to ask for information about a name to be translated to an IP on the web. So we see a lot more info here with our ipconfig. Now let's take this onwards and let's talk about one of our network testing tools that we like to bring up, and that's going to be ping. Ping stands for Packet Internet Network Groper. And the idea of ping is we want to reach out and touch something. So what I can do is type the command ping, and I can follow it by a target. And that target can be a Cisco target like 208.67.220.220, and I'll hit enter, and my machine is going to toss out ICMP echo requests. And these are 4, that's how Windows does it, 4 echo requests. And when they go out, I get 4 echo replies back. I said 4, are you there at this address? And I got 4 responses, yes, I'm there at that address. So I can see that I have reachability. Now this just tests layer 3 regarding the idea of the network layer of the OSI model. And what this is referring to is I can reach something by targeting an IP address. But what if I want to make sure that my PC can actually reach something by targeting a web address? What if I said, for example, this, ping www.cisco.com. By doing this, I'm telling my computer to reach out and hit the name cisco.com, which means step 1, when I do this, my PC is actually going to the DNS server that we've seen above and saying, DNS server, who is cisco.com? Cisco.com is being translated to an IP address, and then my PC goes out and pings that IP address. We're getting responses back from that IP address that my PC found was 104.66.32.105. You can see here that we've sent 4 echo requests and we've got 4 echo replies. Nothing was lost. We have 100% success. So that's ping and that's ipconfig. And for both of these, you can use your help modifier and command line, and that's again going to be your slash followed by a question mark, in order to be able to view other options that exist, because there's many of them, and we can take a long time going through those, but we're not going to do that. Now, what if we want to just test DNS? To test DNS, there's a command called nslookup, and following the command nslookup, you could just hit enter and get into a DNS lookup mode, or we can just follow it with a target. For example, I can follow up nslookup with www.cisco.com. And if I hit enter, my computer polls and says, hey, DNS server 1111, who is www.cisco.com?
And the response we get back is cisco.com is the IPv6 address you see listed here, or it's the IPv4 address you see listed here. Now you can try a couple different targets and see what comes back. Not all targets will come back with an IPv6 address. Some websites have not made that transition to dual stack, which is IPv4 and IPv6 running at the same time. So this is all fun and cool, but this is how you can check to see if you actually have successful DNS lookups to a website. Now, on top of all this, there's another command that we like to bring up, and this one is called netstat, and this is a personal favorite of mine. There's a lot of options for netstat, so make sure you use the help command to really view them all. With netstat, what we can do here is take a look at open ports and connections from our machine right now. Like, what is our machine connecting to right now on the network? Well, following netstat, there's a couple different modifiers and switches I like to use. The main one I do is -b. With -b, this is going to give us the actual process of our machine that is opening this connection. Also, I'll use -n because I don't want to have to wait for DNS name resolution for each individual session my computer has at this moment. I'll go ahead and click enter. Now, boom, it failed.
Yes, here I would like to stop what you're facing the problem now. So when we try to do the tracing or pinging from our host to the server side, if you are not running yourself as an administrator or privileged supervised user, then that will give this error. Your request to the operation requires the elevation. So in that case, the network administrator should take care of that. The ping command should run through the administrative privileges. So then only it can successfully trace out whether the server or the destination is reachable or not. So that you can see in this.
Hold on you. Why? Because when I created this command prompt, I created it from the user account of student. This requires elevation. This is a system command that I need to open up another command prompt and be able to use permissions of administrator. Let me show you. I'll click start. I'll type command prompt. And I'm going to use the run as administrator option, where I could have just right clicked on it and did run as administrator. When my new window opens up, yes, I want access. And here we are with the default directory of Windows System 32. Again, I'm just going to back up using my CD / and now I'll do it again. Netstat. And then followed by -b.
If you check it here, now you're in the C drive in your operating system where it provides the services that System 32, which gives the services to enable the ICMP. For users, like for student user, for any other guest users, these services are disabled actually. So that's the reason the reachability means ICMP packets are not going to be work out in that ping. The reason is in that ICMP, as we said, they have the code of your 0, 1, 2, 3, and 4. So what it is given in the previous one, it is not reachable. It requires some the administrative duties type. That means that message belongs to whether your code 0 or 1 or 2 or 3, that you can identify with that.
-n. When I click enter this time, take a look at this. Based off of the services and protocols and applications running on my machine, I can take a look and see my PC's IP address and port number, known as a socket, source, reaching out to this destination target and port number, that destination socket, and then what service is being utilized on my computer. Now, if you had other applications open inside of here, there's Microsoft Photos.exe, there's a connection out, there's this one that's connection out. You can read through all these different items. And we don't have any name translation because I used -n as a switch. And here we can see these number one .axes and other items because these are based off of the -b switch. So have some fun with it and use your tools to troubleshoot your connections, view what's occurring, and verify what your machine is connecting out to on the web. Again, you can spend a lot of time with these commands and switches, so please make sure that you use that help command. For example, netstat /?. When I hit enter, we see all the switches and possibilities for using netstat.
Yeah, so that's the way of pinging and it will give you that the request operation required the elevation means your network, you don't have your service is not enabled. So yeah. So in this ping test connectivity, whatever you just observed, the ping is your the IPv4 and IPv6 testing utility that uses your echo packets, ICMP echo packets request and your packet reply. So in this test connectivity to another host on the network, we use the command for the host. We're using the command, the ping command, which is followed by the IP address of your destination side. So if the host at this specific address received this echo request, it will respond with the echo reply packet. So as each echo reply receives the ping, that provides the feedback that whether your host is reachable or not by in the echo reply packet. So after all the requests are sent to your host side by ping, that provides the summary that how many packets are successfully transferred and how many packets are successfully received or how many packets are dropped. So it gives that. So the type of connectivity test that performed with this ping that includes ping the local loop back is one, ping the default gateway, and ping the remote host. That means ping your device, whether your device is running or not. Whether your device is running or not means ping yourself. That means the ping your address is your own IP address. So that gives the loop back. And another one is your ping the default gateway means if your host is connected to your router and that router is connected to another router, suppose router 2 and router 1, and that is connected to your host 2, suppose. In that case, first is doing loop back, you are doing the ping with your IP address, suppose 192.168. Your 1. Suppose 15, then you are pinging yourself whether you are reaching yourself in the network or not. Second one is pinging the default gateway, that is ping the IP address of your router, which is the default gateway or network edge router. Suppose this router is having the 192, the local address, that means this interface address. Okay, 192.168.1.1. It is a default gateway. Default gateways basically use the host number as 1. So then it will check whether you are able to reachable to your R1. Then try to ping the next router. Suppose next router is on another the network. Suppose 192.168.2.1. The second network. Then try to ping to the next router, because up to here if it is reachable then you will get the echo reply packet. That means the connection is okay, the connectivity is okay between H1 and your R1. But when you are trying to reach R2, give its destination IP address 192.168.2.1. if it is reachable then it will give you the response. So that is pinging the default gateway and then pinging the remote router, and after that you may ping to the remote host. If remote host is having the IP address that 192.168.2. Suppose 15, then you try to ping that 192.168.2.2. So that is you are pinging the remote host, okay, to test the connectivity. So in this, to ping the loop back, so the ping can be used to test the internal configuration of your IPv4 and IPv6 as said. So for loop back, we use the IP address of your 127.0.0.1 for your IPv4 and your double hash of your the one for your IPv6. So that gives the local loop. And if it is going for the pinging to the default gateway, for the default gateway, the ping can be used to test the ability of a host that can communicate with the local network within the local network. So you are just providing the IP address of your default gateway, that is router 1. And another case is pinging to in this you can find out that from this host pinging to this IP address whether it is reachable or not. So sending this echo request packet, for that if it is reachable it will give you the echo reply packet, the default gateway. So pinging to host, that is pinging to your remote host, as just discussed that if the H1 wants to communicate with the remote host with this or within this network, then it can go through that particular echo packet goes through your default gateway. From that default gateway it reach to the remote host. So let us see this this, let me just play this so that you can understand. Check it out, this animation. So your echo reply packet goes in the same path. So there is a unicast communication which takes place here to check the connectivity of your H1 and your H2 at different locations. So your H1 is on network 10.0.0.1 and your host 2 on network your 10.0.1.1 network. They are on different networks. So this traceout test path is another one. So ping is basically used to test the connectivity between the two hosts, but does not provide any additional information about the details of those devices between the hosts. So whereas your traceout or your traceroute, okay, or you can the command you can use the traceRT also, is the utilize the this utility is used to generate the list of hops. List of hops means how many devices existing in between your source and the destination. So that was successfully reached along that path. So this list can be provided, provide the important verification as well as the troubleshooting, because as we checked, we host 1 ping to your R1, then host 1 tried to ping to R2, then host 1 tried to ping to your host 2. So in the similar way, if you use the trace route and just giving that trace route of your destination IP address in the echo reply packet, it will give all the in between or existing devices IP addresses, so that after that you can start doing the pinging from your local host to your gateway, then local host to your through gateway to your remote gateway. From there you can reach to your host 2. So that is the importance of your trace route. So if the data reaches to the destination, then the trace lists the interface of every router in the path that between the host, and if the data fails at some hop along the way, then the address of that last router that responded to the trace can provide an indication where the problem and security restrictions were found. So this is trace route basically used to ping to the your H1, try to ping to your H2, and so for that it goes through its default router 1, your router 1 connected to your default router 2 of another one. So this router, if it is configured with the firewall, suppose the firewalls or intrusion detection system, then in that case your router will not forward the echo packet of your H1 to your H2, because if that is not matching with the predefined rule of your firewall, so there it drops that packet. So when it drops that packet, from this interface of your router, the echo packet will goes to on your host and inform that network connection is there, but protocol is not enabled, so your service is not reachable to your host 2. So this in this, the round trip time, it may be your ping, or it may be your the trace route. The round trip time plays an important role. So the trace route provides the round trip time for each hop along the path and indicates if a hop fails to respond. So round trip time means, if host 1 sending an echo packet to your router 1, then the time which is taken, travel from your H1 to your R1, and the time taken to process this echo packet by your R1, plus time taken to, the travel time from the echo packet reply from your R1 to your R2 gives the round trip time. So this round trip time is the time a packet that takes to reach the remote host and for the response from the host to the return. So in this, the traceout test path, if you see in this case, the root traceout, the time, IPv4 time to leave or IPv6 hop limit, the traceout uses this function for your time to leave field in your IPv4 structure, TTL. So this TTL provides how many hops it can travel, and after that automatically it will be discarded from this network. So if here in this case, if you see the example, the traceout, the first sequence of message that sent from your Traceroute have the TTL field of value 1 here, so which causes the time to leave to timeout at IPv4 packet at the first router itself, at this router. If it is written as 2, that means that will be reach up to your second router. If it is time to leave is suppose 3, there will be 3 hubs, so it will try to, it will reach to your router 3. But every time, if it is 3 is mentioned in time to leave, then every time from here it reached 3, when it reached to here it become 2, when it reached to here it become 1. And after that, it will not forward to any other routers, it will forward to any of the end devices in that network. So after the final destination is reached, the host responds with either the ICMP port unreachable message or ICMP echo reply message instead of your ICMP time exceed messages. Yes, please.
So when you get to inside of the network of like host 2, does the switch also count as a hop?
No.
Okay.
No. Only network devices means which are having the public devices. The public network devices means hubs, number of routes, routers inside the network. Yeah. So if you see the packet format of your ICMP, so here it finds the time to leave field in ICMP that gives. So ICMP is encapsulated directly into your IP packets, because ICMP is the version of your IPv4 and IPv6. So it gives what type of services it will provide. So this ICMP acts as a data payload as well as your with the IP packet. So it has a special header field that called your code, as we discussed. If this code is 0 means echo reply. If the code is 3 means destination unreachable. If the code is 5 means it is redirected. If code is 8 means echo request for the ping, and code is 11 means time exceeded for your time to leave become. So this part is important in the ICMP header bytes. So which is the added, and this act as your data payload in your TCP IP. So there you might when we talked about the TCP IP suite of your IPv4 version, there we find that after source IP address and destination IP address, you are having the payload part. So that payload occupied by ICMP. So in that ICMP, it consists of the code. That code responds whether the destination is reachable or not. So in this connectivity verification, if you try to summarize that, the TCP suite sends the ICMP messages when IP packets encounter forwarding problems, and this ICMPv4 for your protocol version 4, IPv4 version, and it can be used for your IPv6 also. But in IPv6, it gives some additional information. The additional 4 IPv6 messages. One is your neighbor discovery protocol. So in that neighbor discovery protocol consists of the router solicitation message, router advertisement messages, and your the neighbor solicitation message and your neighbor advertisement messages. And by pinging from host 1 to your host 2 through the network, the ICMP echo request and echo reply messages are exchanged to check the connectivity between the host. And some type of connectivities that test the that are performed with this ping, that includes the local your loop back that gives your pinging yourself. So it use the IP address your 127.0.0.1 IP address. So that is loop. And second one is your default gateway. Third one is pinging to your remote host through your remote gateways. And the alternate to your ping is your trace out. This trace route information gives what are the intermediate devices are there. All those devices, the IP addresses are the information will be given. So this is about the connectivity verification. So I hope when you try to do the lab of doing this connectivity verification, only important thing is to remember that you must run your the command prompt or terminal in your Linux operating system into the supervised privileged user. So then only it is possible to activate that service to reach the destination side. Okay. So once the connections are established, let me quickly go through that. The next class we'll try to discuss the next topic, that is the address resolution protocol. I'll just give you the quick information about that. So in the next class, we'll try to discuss the address resolution protocol. So up to now, if we summarize all the topics, you have seen that, what are the end devices in the network, what are the network devices in the network, how they are connected. If they are connected, then what are the different protocols are used to exchange the information in between the devices by using the TCP IP model. So in that, network protocols plays a major role. So once they are connected in the network means they will be identified with the IP address and your MAC address. Then once they are identified with the IP and MAC address, try to check it out whether the connection is established or not. That means that gives the reachability, that verifying the connectivity whether one host is reachable to another host or not. So once they are trying to reach one to other, then the first and foremost part is how they can know each other in the network, because when the network established, every host knew to every other host. But every host, they are having their own MAC address. Physical address is unique. By using that MAC address, how can they get the IP address of other users in the network? So once they get the IP address of other users, then they can go for the connectivity purpose. Connectivity very quick, because they have the IP address of other hosts. Then they can check whether their hosts are reachable or not. If they are reachable, then you can start communicating. So to get the IP address of other hosts, we use the protocol called the address resolution protocol by using the MAC address. So in this address resolution protocol, it analyzes the address resolution protocol of your protocol data unit on a network, and it will be it will cover the MAC address and the IP address. It compare the roles of your MAC address and your IP addresses in the network, and how this address resolution protocol that examines the Ethernet frames, the MAC address frames, and resolve the issues of your IP address. So this we try to discuss in the next class, how the devices are having, any device in the network, they will have two addresses. So basically they will have the MAC address. By using MAC address, how to get the IP address of others. Once you have MAC address and IP address of others, then how this address resolution protocol is used to solve the Ethernet framing. That means to send or broadcast or unicast or multicast the packets within the network without IP address, or within the network with the help of your MAC address. Okay, that we'll try to discuss in the next class. So